Hello everyone, I am going to explain about our project Automation of GH2 charging using PLC and Scada. Here GH2 refers to gaseous hydrogen, PLC refers to programmable logic controller, and Scada refers to supervisory control and data acquisition. The main objective of our project is to automate the process of GH2 charging of gas bottles present in ATV using PLC and Scada. Here ATV refers to Advanced Technology Vehicle. Next, why we go for automation? Since filling of GH2 gas manually is a difficult task and also a risky task, so we go for automation. So here we are operating the valves automatically based on the initial conditions. By switching to automation, we are minimizing the human interventions and increases safety of personnel. Before going to give a detailed explanation about our project, let me introduce about the Advanced Technology Vehicle. The Advanced Technology Vehicle is a modified Indian sounding rocket developed by Indian Space Research Organization. First stage of ATV is called the booster and the second stage is the sustainer. Both the booster and the sustainer are provided with the fins for aerodynamic stability. The fuel feed system is positioned above the sustainer motor and the nose cone payload on the top of the fuel feed system. The scramjet engines are mounted diametrically opposite at the end of the sustainer motor. Gaseous hydrogen has been chosen as the fuel for the scramjet engines. Air required for combustion is drawn from atmosphere through the air intake system, while passing through which it is subjected to multiple oblique shocks which raises the pressure and temperature of air. This will facilitate the auto-ignition of gaseous fuel injected through the engine struts under choked flow conditions to the hot air stream passing through the combustion chamber. Even though auto-ignition of the fuel is expected to occur as a redundancy, pilot igniters are also provided in the engines to ignite the air-fuel mixture in case auto-ignition does not happen. Gaseous hydrogen feed system circuit consists of gaseous hydrogen fill valve, which is used for charging the gas bottle to a pressure of 27.5 megapascals. A vent valve similar in configuration to the fill valve is used for venting the hydrogen gas in case of an emergency. This is the block diagram of our project. The block diagram of our project consists of Scada, PLC and field equipment. The PLC used here is a Schneider Premium PLC. The hardware part of PLC consists of power supply, CPU, analog input card, analog output card, discrete input card, discrete output card. All these components are inserted on a backplane. Here PS53610M is the power supply port which uses a power supply of 24 volts. P572634M is the CPU. ETY port is the Ethernet port. DS532D2K is the discrete output port. DEY32D2K is the discrete input port. AS5800 is the analog output port. AEY810 is the analog input port. Next, what is PLC? PLC is an industrial computer that monitors inputs, makes decisions based on its program, and controls output to automate a process or machine. A PLC has a built-in operating system. This operating system is highly specialized to handle incoming events in real time or at the time of their occurrence. There are so many controllers for automation, but we opt for PLC because it is a digital computer designed for multiple inputs and output arrangements, for extended temperature ranges, immunity to electrical noise, resistance to vibration, and above all it can work under harsh conditions. Scada is an acronym for Supervisory Control and Data Acquisition. It is a real-time industrial process control systems used to centrally monitor and control remote or local industrial equipment such as motors, valves, pumps, relays, etc. A Scada system gathers information such as where a leak on a pipeline has occurred, transfers the information back to a central site, then alerts the home station that a leak has occurred, carrying out necessary analysis and control such as determining if the leak is critical and displaying the information in a logical and organized fashion. We use a Visual Cytec software for Scada that manages and monitors the process in manufacturing, primary production, utilities delivery and facilities management. We use a Unity Pro software for the PLC which allows user to create redundant PLC applications without using any special hardware. Unity Pro offers functions and functionality which frees you to create software for synchronizing PLCs or for making intelligent input-output stations. This is our simulation results. This is the two GH2 modules which stores the hydrogen gas initially. and this is a GN2 module which stores the nitrogen gas. These two represents the GH2 gas bottles which has to be filled, which is the main aim of our project. These represents the valves which is opened or closed based on the conditions. There are two types of valves. One is electro-pneumatic valve and the other is a pneumatic valve. Electro-pneumatic valve operates by using both electricity and pressure, whereas pneumatic valve operates by using only pressure. It has GHFV, that is gaseous hydrogen fill valve, which is used to fill the gaseous hydrogen bottles, and GHVV, that is gaseous hydrogen vent valve, which is used to discharge the gaseous hydrogen when required. We use gaseous nitrogen to create pressure for operating the pneumatic and the electro-pneumatic valve. Now first we'll check for the initial conditions. We'll check the pressure at terminal 1. Here the pressure should be greater than 27.5 megapascals. If the pressure is greater than 27.5 megapascals, the valve VP1 will be open, otherwise it is closed. After that, we'll check the pressure at terminal 2. Here the pressure should be less than 1 megapascals. If it satisfies this condition, the valve VP2 will be opened, otherwise it is closed. Again, the pressure at terminal PT302 and PT304 is checked. Here the pressure should be greater than 35 megapascals. If it satisfies this condition, the valves VP301 and VP302 will be open. If you want to charge the GH2 bottles, only the valve VP301 should be opened in order to create the pressure by the GN2 module for opening the gaseous hydrogen fill valve. The valve VP302 will remain closed in order to keep the gaseous hydrogen vent valve closed. The gaseous hydrogen vent valve will only be open for discharging the gaseous hydrogen from the GH2 bottles when required. If all these conditions are satisfied, GH2 bottles starts charging. During charging of GH2 bottles, it will also check for the charge rate surveillance and temperature. Charge rate surveillance is nothing but the rate of charging of GH2 bottles, and it should be greater than 2 bar per minute. The temperature of GH2 bottles should be greater than 45 degrees. If these two conditions are satisfied, then the GH2 bottles keep charging. Otherwise, it will close the VP1 valve and stops charging. Thus, we automated the process of GH2 charging of gas bottles. Thank you.